This section will cover the advantages of ABS and EBS braking systems over conventional braking systems. Please watch carefully as you'll be asked about the information covered in this section.
Welcome to Atkinson and Rosendale College, Motor Engineering Department. Today we're going to look at electronic braking systems, abbreviated with the term EBS. In particular we're going to look at ABS, anti-lock braking systems, and for this unit you will need to have done some prior learning on conventional braking systems. Anti-lock brakes, or ABS, prevent wheel lock-up. During hard braking, particularly in an emergency, the driver tends to stomp on the brake. During this reaction, to avoid an incident, one or more of the wheels may lock up during braking. Electronic technology, as mentioned before in EBS, the ECU gathers speed from each wheel and recognises the input signals have changed during that braking when one or more of the wheels was locked up. As soon as a wheel starts to lock up, electrovalves inside the module relieve some of the brake pressure to the affected wheel, and as soon as the wheel starts rotating again, then reapply the pressure. The main advantage of having ECU control our braking pressures is that during that response by the driver in an emergency situation, he is able to maintain the steering of the vehicle. Hi everyone, welcome back. We've done our concentration on ABS. Now I'd like to talk about EBS again, electronic braking systems. This is an extension of showing how technology has advanced using ABS technology to link in other vehicle systems. Electronic braking systems, relatively new technology to vehicles. Around about 1980s, first technology started to come into motor engineering. Since then we've had a lot of developments and interlinking with other systems. A series of electronic components monitor the position and speed of the vehicle and the reaction of the driver and how his driving can be affected by the braking system. EBD stands for Electronic Brake Force Distribution, can sometimes be abbreviated as EBFD. This is an addition and combination of using anti-lock braking technology with conventional technology. Conventional braking systems use a load compensating valve to adjust the rear braking effort depending on the inertia forces applied during braking. Anti-lock braking ECU recognises the forward movement or the dip in the front end of the vehicle and applies braking pressure to the rear brakes to level up the car. This supplies more brake fluid pressure to the rear brakes and compensates for the upward lift of the rear of the car, keeping the car level at all times, maintaining contact with the road surface with the tyres. Another advancement on anti-lock braking system is the EBA system, which stands for Emergency Brake Assist. The driver may unintentionally apply the wrong amount of brake pressure to apply effective braking in an emergency situation. The ECU, however, recognises the speed of movement applied to the brake pedal and overrides the driver's intention or unintention to apply insufficient pressure. It then communicates with the anti-lock braking ECU and applies the required amount of pressure to carry out the emergency stop. If EBA is unnecessary and the driver didn't intend to brake as hardly, the driver simply releases his pressure on the brake pedal and overrides the ECU. So the next advancement using ABS technology is ESP, or sometimes called ESC. ESP stands for Electronic Stability Program, and it's related to the electronic stability control. In this system, the steering action of the driver is not always following the intended path. So using sensors connected to the steering, the ABS ECU is able to apply individual braking to the outer front wheel in the case of oversteer, and in the case of understeer it applies individual braking to the inner front wheel to correctly guide the driver on the intended steered path. Electronic Stability Programme, or ESC, an example of this might be travelling along the motorway and a load falls off the back of the lorry. Instant driver reaction is to swerve to pass the object. Unfortunately, in most cases, the driver will actually turn the steering wheel too much, causing an oversteer situation and the tendency for the rear end to continue round in a circular motion. However, ABS will apply the outer front wheel to counteract oversteer and set the driver on his intended path. Once he's started to head in the right direction, the driver often overcorrects the steering that's just been achieved and then creates another situation called understeer, where again the vehicle rear starts to shift, and what the ABS ECU will then do will apply individual pressure to the inner front wheel to counteract this understeer situation. TCS, or traction control system. In this system, the intervention of the ABS ECU communicating with the engine management ECU and looks at modifying the overall final drive wheel speed. This can be achieved by applying the brakes using the ABS ECU, or the ECU sending information to the engine management ECU to reduce the throttle. This will take place without the driver noticing any effect. An example of traction control might be a slippy, snowy situation on a road where the driver tends to accelerate thinking that he's going to get away from the muddy or snowy road situation. This actually causes the vehicle to skid more. Instead of the driver having to release the accelerator and try to go slowly, the ABS ECU talking to the engine management ECU might decide to slow the engine down for the driver, or apply a brake to increase the traction.